Today we're going to be talking about identifying parallel and perpendicular lines when you're given the equations of those lines. And so if we look, here we have two lines. We have a green line and a red line, and they are parallel. But why are they parallel? Well, first off, let's look at their slopes of these two lines. Looking at the red line, it looks like it crosses grids right there and possibly right here. So change in y over a change in x. So that means we went down 3 and to the left 1. So for the red line, m, the slope is equal to -3 over -1, which is equal to +3. And let's look at the green line now. The green line, it'll cross right here and right here. And we'll do a change in y over a change in x. The slope for the green line, the change in y was -3, and the change in x was a -1. And if we reduce that or simplify it, +3 is the slope. So if we look at the slopes of parallel lines, they're going to have the same slope. Parallel lines have the same slope. If we're given two equations like this, we're supposed to decide whether the graphs of those two equations are going to be parallel. So if we're looking here, this first equation here on the left, m is the number in front of x, so that's -5. We don't need to worry about the y-intercept in this case because when we talk about parallel lines, they only have to have the same slope. They don't need to have the same y-intercept. On the right side here in yellow, we have to get y by itself, so we subtract 5x from both sides. On the left side, the 5x's cancel out, and you're left with y. On the right side, you cannot combine -4 and -5x because they're not like terms. So we'll put it in slope-intercept form. And the slope here is the number in front of x, -5. So are these two lines parallel? The one on the left has a slope of -5. The one on the right has a slope of -5. And since they have the same slope, those two lines are parallel. Once again, deciding whether these two equations are parallel, it's going to take a little more work here to solve these ones. Trying to get y by itself. I want to add 6 to both sides here. That leaves us with y plus 4x, which is equal to, those 6's canceled off, and 0 plus 6 is 6. We still don't know the slope yet, because we don't have y by itself. Going to subtract 4x from both sides, so therefore we have y, 4x is canceled off, and on the right side 6 and negative 4x are not like terms. The 6 is a positive 6, so we're going to write plus 6. So for this blue equation here, the slope, what's the number in front of x? Negative 4. The slope is negative 4. If we look here on the right side now, to get y by itself, all we have to do is divide by 2. And we divide everything by 2. The 2's cancel off. So y is equal to 16 divided by 2 is 8. X. 12 divided by 2 is 6. So if we're looking, y equals mx plus b, we have it in slope-intercept form. Slope in this case is 8. Slope on the left side is negative 4. The slope on the right side is positive 8. Those are not the same numbers. So those two lines that we originally started with are not parallel. Looking here at this one, let's looking here on the left side at the green equation, trying to find the slope here, so we're going to get y by itself. So you subtract 3 from both sides, you're left with y minus 2x is equal to 6x, and we have negative 1 minus 3. Negative 1 minus 3 will give us negative 4. Still trying to get y by itself, so we have to add 2x to each side. And we're going to add 2x to 6x because they have like terms. The x is the like term. Those cancel off on the left side. We're left with y is equal to 6x plus 2x will give us 8x. And we drop down our negative 4. So over here on the left side, the slope is 8. Now let's look here on the right side at the pink equation. We're trying to get y by itself. First step would be the opposite of positive 4x is a negative 4x. So that's the reason why we are subtracting 4x from both sides. 4x minus 4x leaves us with nothing. We drop down our negative 1/2 y, and that's equal to negative 4x, and we have a positive 3 there. What do we need to do here to get y by itself? Well, we're trying to get a 1 in front of the y, so what number do we have to multiply 1/2 by to get a 1 there? We have to multiply it by 2. And since we have negative 1/2 y, to get rid of the negative sign, we have to multiply it by a negative, because a negative times a negative will give us a positive. And 2 times 1/2 will give us 1, and that's the reason why we're left with y on the left side. Now remember, if we multiply the left side by negative 2, we have to multiply the right side by negative 2. And let me put a multiplication sign there. We'll put a negative 2 right there in parentheses. And from here, we have to use the distributive property. So negative 2 times negative 4x. Well, negative times a negative is going to give us a positive. 4 times 2 is 8, and we have x left over. Our next step is negative 2 times the positive 3. That gives us a negative 6. In this case, the slope is the number in front of x, which is 8. Slope on the left side is equal to the slope on the right side. Since those slopes are equal, since they are the same, then those two lines are parallel. Right here is an example. Why don't you go ahead and try and find the slope of this equation, actually find the slope of both equations and compare them. If they have the same slope, then they're parallel. If they do not have the same slope, then they're not parallel. You may want to go ahead and pause this and take a few moments. I will work the solution out right now. For the left side, the yellow equation, we're just basically going to rewrite it. We're going to put the y is equal to on the left side 3x minus 6. This is in slope-intercept form, and therefore m is equal to the 3. On the right side here, we just have to do a little rearranging here. This 3x is positive, so we're going to put a positive 3x there, and this 10 is also positive, so that's why we put a plus 10. And the slope in this case, y equals mx plus b, m is going to be equal to 3. And if we look at the slopes, they are both the same, so those are parallel lines. Those two lines are parallel. Here's another example that you can work out on your own. Go ahead and pause the video, take a few moments to work this out, and then I'll work through the solution in one moment. Trying to get y by itself here, so we subtract 5x from both sides of the equal sign. We drop down, it's a negative 6y, so we're going to drop down negative 6y is equal to negative 5x. The 3 is positive, so we put a plus sign with it. Still trying to get y by itself, we have to divide the left side by negative 6, and we're going to divide everything on the right side by negative 6. And so we're left with y is equal to negative 5 divided by negative 6. We know negative divided by negative is going to give us a positive, and there is nothing that will go into 5 that also goes into 6 other than 1. So we cannot reduce 5 over 6. We just write it as 5 over 6x. We're looking at the positive 3 divided by negative 6 now. Positive divided by negative will give us a negative, and 3 divided by 6 will reduce. 3 goes into both of those. So 3 goes into 3 one time, and 3 goes into 6 twice. So we have transformed this equation to look like y equals 5 over 6x minus 1/2. And the slope in this case is 5 over 6. So let's look here at the blue equation now. Let's see if we can figure out how to get y by itself. First off, we're going to add 3 to both sides. Those cancel off. On the left side, we're left with 5y is equal to 6x plus 3. To get y by itself, you divide by 5, divide everything by 5. 5's cancel, so y is equal to 6 over 5 x plus 3 over 5. And the slope in this case, 6 over 5. Compare the two slopes. The left one is 5 over 6. The right one is 6 over 5. Those are not the same slope, so those are not parallel lines. A vocabulary term here at the very top is called a reciprocal. Reciprocal. So if we look at the first line there at the top, the reciprocal of 5 over 6 is, well, when we look for the reciprocal, we just basically flip the fraction there. So the reciprocal of 5 over 6, 6 over 5. Look at the next one. The reciprocal of 2 is, well, in the first example, we had 5 over 6. It was a fraction. In this one, we do not have a fraction. I guess we kind of do have a fraction. You just have to make it into a fraction. So it's going to be 2 over 1. So 2 is equal to 2 over 1, and the reciprocal of 2 over 1 is 1 over 2. Look at the next one, the reciprocal of negative 1 over 2. Well, if you just look strictly at the fraction, the reciprocal of 1 over 2 is 2 over 1, and the negative sign will go with it. In this case, when you just talk about reciprocals, you keep the sign that's with it. And on the very bottom one, the reciprocal of 1 is, once again, we got to make 1 a fraction, which is 1 over 1. So the reciprocal of 1 over 1, we flip it, we get 1 over 1. And that is just 1. 1 over 1 is just 1. Can I take a step back here? Can I take a step back to the third one? This last one got me thinking about the third one. Negative 2 over 1 should just be negative 2. Negative 2 over 1 will simplify into negative 2. So make sure you always reduce fractions and simplify them if possible. All right, we showed you reciprocal here for one reason, is because we're now moving into perpendicular lines. And when we talk about perpendicular lines, we're going to start off by looking at the red and the green line. They are perpendicular, but why are they perpendicular? So let's look here. Let's find the slope of the green line first. Find the slope of the green line. It looks as if it'll cross right here and maybe right here. So let's do rise over run. The rise, it rises 1, 2, 3, 4. And rise over run is just like change in y over change in x. And let's do the change in x here. 1, 2, 3, 4, 5, 6. So this is 6. So for the green line, we're going to find the slope, the change in y. Well, it went up 4 over the change in x. It went to the right 6. 4 over 6, they're both even numbers, so we know 2 goes into both of them. 2 goes into 4 twice, and 2 goes into 6 3 times. So the slope of the green line is 2/3. Now let's find the slope of the red line. I see a point there, and I see a point here where it crosses the grid lines. So let's do the change in y. Change in y, 1, 2, 3. Slope of the red line. The change in y was negative 3. And let's do the run. Change in x. It is 1. It is 2. And since it went to the right, that's a positive number. So we have negative 3 over 2 for the slope. And typically, you'll see the negative sign move off to the side of the fraction bar, and you'll have the 3 on top and the 2 on bottom. So let's look at those slopes. The slope of the red line is negative 3/2. the slope of the green line is 2/3. Well, they look like reciprocals, other than the green line is a positive and the red line is a negative. The slope for the red line is a negative. Um, and that's key when you find the slope of perpendicular lines. We can look here. Perpendicular lines have opposite reciprocal slopes. Opposite reciprocal slopes. So that means on this example, for the green line, 2/3 was the slope. Well, the opposite of positive 2/3 is a negative, and then the reciprocal of 2/3 is 3/2. So the opposite reciprocal slope for those lines is going to be 2/3 for the green line and negative 3/2 for the red line. I've come up with some examples here. There's 4 examples. See if you can calculate the opposite reciprocals for those 4 slopes. I will work through those here in one moment. If we look on the very first one, we look at number 1 here. M is equal to 3/2. Well, the opposite of that positive 3/2 is going to be negative, and the reciprocal of 3/2 is 2/3. So if you were to have equations of lines that had 3/2 for a slope and another line that had negative 2/3 for a slope, those would be perpendicular. Let's look here at number 2. Since m is equal to -5, well, we know -5 is -5/1, so that's going to help us out. The opposite sign of negative is going to be a positive, and 5/1, the reciprocal of that is 1/5. Now, we don't typically leave that positive sign there, so we're just going to say 1/5. 1/5 is the opposite reciprocal slope of -5. Let's look here at number 3. Number 3, the slope is -1/3. Well, the opposite of negative is a positive, and the reciprocal of 1/3, 3/1. And now let's simplify this if we can. We don't need the positive sign, but 3/1 will simplify to 3. So there is our opposite reciprocal slope, 3. Now we do have some variables in this last one, in number 4. We have some variables, but it still works the same as what you've been doing with the first 3 examples. We have a positive 4x/y, so then first step, it becomes negative, it becomes opposite of positive, and then we flip that fraction, y/4x. Now, we know that x cannot equal 0. X cannot equal 0 because 4 times 0 on the bottom of that fraction would give you 0, and that's not allowed. That last thought, I just had a moment there. On that last thought, 4x/y, you can't, I guess you can have, x can be negative, because if x is negative, or I'm sorry, not negative, if x is 0, then that makes the bottom 0, which puts this at a vertical line. Vertical lines have a slope of 0. So in this case, vertical lines will have a slope of 0. Or not a slope of 0, an undefined slope. That's when 0 is on the bottom. So going back to number 4, you have positive 4x over top of y. So the opposite of positive 4x is a negative. And on the bottom, you have y. So you move that to the top. And then 4x will move to the bottom for the reciprocal part of it. So you have negative y over 4x. Let's move on and look at some of these examples here. Decide whether the graphs of the two equations are perpendicular. Well, if we look here, the slope here is negative 3/2. The slope here on the right side is 2/3. Well, on the left side, we know that this is a negative, and on the right side, that's a positive. So far, we meet the part of them being opposite. Now, the slope here is 3/2. What is the reciprocal of 3/2? That's going to be 2/3. So those two lines are going to be perpendicular. Looking here at this next set of equations, are these going to be perpendicular? Well, let's find the slope of them. First off, we're going to try and get y by itself. 5x's will cancel on the left side. So 2y is equal to negative 5x plus 8. Get y by itself, you divide by 2. You divide everything by 2. 2's cancel, and y is equal to a negative 5 divided by a positive 2 is a negative 5/2 x. And 8 divided by 2, since they're both positive, the answer is going to be positive, and 8 divided by 2 gives you 4. And the slope in this case is negative 5/2. Let's look at the right equation, trying to get y by itself. Add 15 to both sides. So 5y is equal to, those 15's canceled off. We have 2x plus 15. And divide by 5. Divide everything by 5 to get y by itself. So here we have y is equal to 2/5x plus, and 15 divided by 5 will give us 3. The slope on the right one is 2/5. So let's look. Here we have a negative. The opposite of negative is a positive. We've met that requirement. And on the left side, we have 5/2, and the reciprocal of 5/2 is 2/5. And these two lines are going to be perpendicular. Looking here, deciding whether these two lines are going to be perpendicular, we are going to get y by itself. So on the left side, let's start by adding 6 to both sides. So 3y plus 4x is equal to 3 plus 6 is 9. Next step, moving the 4x to the other side. Do that by subtracting 4x from both sides. We're left with 3y is equal to negative 4x, and the 9 is going to be positive, so we put a plus sign there. We got to get y by itself, so we divide everything by 3. The 3's cancel off, and we're left with y is equal to negative 4/3 x plus 9 divided by 3 is 3. Our slope in this case is negative 4/3. So look at the right side. Not as many steps to getting y by itself here. Divide each side by 4. So y is equal to 3/4x. And this is in slope-intercept form because this is y is equal to mx plus b. In this case, the y-intercept b is going to be 0. That's why it's not written there. So the slope is 3/4. And so let's look at this. If we have negative on the left and on the right, we have a positive. We've met that requirement. They are opposite of each other. And on the left side here, we have 4/3. The reciprocal of 4/3 is 3/4. So those are perpendicular. They have opposite reciprocal slopes. Let's look here at this equation. Let's have you try this on your own. Figure out what the slopes for both of those lines are and see if they are opposite reciprocals of each other. If they are opposite reciprocal slopes of each other, then those are perpendicular lines. If they are not, then they are not perpendicular lines. You might want to go ahead and pause the video, and I will solve these out so you can check your solutions. On the left side there, in the blue, to get y by itself, we're going to subtract 2x from both sides of the equal sign. And those will cancel out. And we're left with y is equal to negative 2x, and the 4 is positive. So m is negative 2. On the right side here, trying to get y by itself, subtract x from both sides. Negative 2y is equal to negative x plus 8. Remember, the 2y is negative, so the negative sign has to come down with it. To finish it off, we divide by negative 2, divide by negative 2, and divide by negative 2. So since everything has been divided by negative 2, y is equal to, well, we know there's an invisible 1 here in front of the x, so negative divided by negative gives us a positive. The invisible 1 on top becomes a visible. 2 stays on bottom, and the x moves off to the side. Now, looking here at the right side, we have a positive 8 divided by a negative 2, which gives us a negative answer. And 8 divided by 2 is 4. In this case, the slope is a positive 1/2. On the left side here, the slope is a negative. On the right side, slope's a positive. So far, they are opposite of each other. Looking here, the slope is 2, which we know is 2/1. And on the right side, the slope is 1/2. They are reciprocals of each other. So these two lines have opposite reciprocal slopes, and they are perpendicular to each other. Here's another example. Go ahead and work this one out on your own. See if they're perpendicular to each other. Might want to pause the video because I'm going to work them out here in one moment. On the left side here in yellow, to get y by itself, we're going to subtract 4x from both sides. The 4x's cancel. We're left with negative 5y is equal to negative 4x minus 2. Divide everything by negative 5. The negative 5's cancel. We have y is equal to. Now we have negative 4 divided by negative 5. So we know negative divided by negative is going to give us a positive. And 4 over 5 does not reduce. So we leave it as 4 over 5. X comes out to the side. And with the next fraction, negative 2 over negative 5, a negative divided by negative will give us a positive. 2/5. 2/5. So y is equal to 4/5 x plus 2/5. And in this case, m is equal to 4/5. The slope is 4 over 5. Let's look here at the green equation on the right side. To get y by itself, we're going to add 6 to both sides. 4y is equal to 5x plus 6. And how do we get y by itself? Divide everything by 4. Those cancel. So y is equal to 5 over 4 x plus, since 6 and 4 are both positive, it's a plus sign there. And 2 goes into 6 and 4, so 2 goes into 6 3 times. 2 goes into 4 twice. And we have our equation. Y is equal to 5/4 x plus 3/2. And in this case, m is equal to 5/4. Now, let's look here. The one here on the left is a positive 4/5. The one on the right is also a positive, so that means they are not opposite of each other. They are reciprocals, but they have to be opposite reciprocals. So these two lines are not going to be perpendicular because they do not have opposite reciprocal slopes. I hope this video has helped you out. We are going to be finished here, and we will see you in the next one.